So in the previous video, we saw what are stacks and what are queues and how do they work. In this video, we will see how to implement stack and queues using Deque data structure in Python. But before that, we will implement stack and queues using array itself. Let's suppose we are given an array of length 4. We first insert 1, then 2, 3, and at last we insert 4 in this array. And our task is to transform this array into a stack. But the thing is, an array in itself is a stack. Let me show you. If you take a stack and push elements, all these elements in stack, we first push 1, 2, 3, and at last we push 4, such that our top element is 4. So now if you perform dot pop method on array, you know the element which is going to be popped is the last element of the array, so the 4 will be popped. So similarly, if you perform if you want to remove the element from the stack, we know the element which we inserted at the last will be removed first. So here also we know that the 4 is going to be popped out. So this is very similar to array. Again, if we want to append an element in array, let's say we append 5. So here, you know, at index 3 the 5 will be pushed. Similarly, in stack, if you want to append an element, it will be at the top of the stack. So this is why the stack is very similar to array. So that's it. We implemented stack using array. So basically array was nothing but stack from the beginning. But what about queue? How to implement queue using array? So things are a bit different here. So let's suppose we are given an array of length 4 again. 1, 2, 3, and at last 4. Okay, so now if we take a queue and if we insert 1, 2, 1 at the beginning, 2, 3, and 4 at last. So if you now perform a dot pop method on array, you know the 4 is going to be removed. But if you want to remove an element in the queue, you know it queue follows FIFO, which is first in, first out. So first in was 1, so it should be removed first. But in array, you are removing the last element. So what can we do? It's again very easy. You will just say array dot pop and give the index of the element which you want to pop. We will say we want to pop first element in the queue. So the first element we inserted in the array was 1, which is at index 0. So we will just say array dot pop 0. So yeah, that's it. We implemented queue using array. So now the question arises, why there is need of the data structure? Because it's very easy to implement stack and queues using array itself. Even though it is much easier to implement stack and queue using arrays, but there is a little twist in here. So let's rewind some things back and let's go to stack. Let's see how we implemented stack using array. So let's say we are given this stack. So to pop out the top element of the stack, we just used array.pop method, and the top element of the stack was popped out. So everything's fine till here. Now things get a bit different with queue. So suppose this is our queue. We inserted 1 at the beginning, 2, 3, and at last 4. So we can't just use the array.pop method, as it will pop the last element of the array or the queue, but we want the first element to be popped out. So we specified index 0 here. But the thing is, the moment we specified index in pop method, the time complexity becomes big of n, which might be feasible for small arrays but will be much slower for large arrays. So this is where the Deque comes in play. Deque solves this problem in big of one time complexity. So deck is nothing but an array or a list with some extra functionalities. So suppose if I draw an array of length 4, I can call this as deck provided it is able to perform some extra functions. So what are these functions that make deck different from array or a list? So like arrays, it is able to pop the last element in big of one time complexity. But it is also able to pop out the element at index 0 in big of one time complexity, which makes it very different and optimal from array. So this is the reason why we will use deck instead of array. So now let's implement what we discussed so far for better understanding. So from collections, I will import deck. So I will create a deck named array, and it as I told you, deck is very much similar to array. So its methods array or what we call list in Python. So it is very similar to list, and its methods are also very similar to list. So we also have append method here. So we will append one, and if I print this array, oh sorry, it's not an array, it's a deck. See, one is appended, and it has also given what data structure it is. It is deck. So I will append some more elements. Say 2, 3, and 4. And let's print this deck. As you can see, the deck is printed with 1, 2, 3, and 4 as its element. Now we also have pop method similar to lists. So the last element will be removed. Sorry, I will print again this deck. So as you can see, the last element is removed. So this is so far this is much similar to list in Python, but what makes deck different from list is now what I will show you. So here we have 4 elements in our deck, and now what we are going to do is we are going to pop the element at index 0 with help of deck. So in deck we have a special function called popleft, which is used to pop the first element in the deck. So now if I print the deck named array, so you can see I first appended 1, then pushed 2, 3, and 4. Wait, let me also print the deck before popping the first element. So as you can see, our deck was 1, 2, 3, and 4. So after popping the first element, our deck is 2, 3, 4. So we can use this pop left function to pop the first element of the array. Also, we have a function called method, to be precise, called append left, which will append the element to the left of the deck. So if I append 5 and print the deck named array, so you can see the 5 is appended at the leftmost of the deck. So this is what it makes a difference between array and a deck, or a list or a deck. Okay, so now how can we implement stack or queue using deck data structure? So we will create a deck named stack, and we will append some elements in it. So stack dot append 1, we will append 2, 3, and 4. So you can see here our stack is created of 4 elements. So now if we want to pop the element, topmost element of the stack, we will just use stack.pop, which will pop out 4 from the stack. So this was our stack initially before popping out the top element, and this is our stack after popping the element. So we can also again append an element and see. So if I append 6 and again print the stack, we can see that now our topmost element is 6. So this is what stack implementation using Deque looks like. So now we will implement queue. So let us create a Deque name queue and let us append some elements in it. Let us print our queue. So you can see our queue is printed, which consists of 1, 2, 3, and 4. So now if we want to pop the element in queue, we know that we have to pop the first element of the queue, which is at the front of the queue. So we will use a method called popleft of the deck, and when I print this queue, we can see that the front element of the queue is popped. So this is what queue implementation looks like using Deque. So now we were able to see how to implement stack and queue using Deque data structure. So that too in a much optimal way than list in Python, which takes a big of n time complexity for popping the element at index 0, which is the front element. So that's it for this video, and in next video we will learn about trees and graphs, which are also very much important data structures and basics for implementing searching algorithms like BFS, DFS, and every algorithm. So that's it. Thank you.